Okay, class. Let's move on to a slightly more involved problem dealing with shear force and bending moment diagrams. So we have here a structure that has a uniform load that we talked about earlier. Okay. Now I'm just going to draw my free body diagram. So for my solution, let me choose a slightly thinner. I'm going to have my support reaction at A and at B. Okay, so this is going to be AY, and I'm going to have, this is going to be BY, and this is going to be my AX. Okay, so we have a uniform load here of 2 kips per feet, right? 2 kips per feet. Now we want to be able to turn that into a force. Okay, so that 2 kips per foot, right? And it's over a span of 12 feet. Okay, so when you multiply that by 12 feet, what happens now is the feet cancel out and you're left with 24 kips. So this is a force right here. So this 24 kips is going to be located at the centroid or at the middle. There's 24 kips for a rectangular shape. You remember for a rectangular shape in our centroids, we noticed that the centroid is located right dead in the middle, right? So this is going to give us over a span, it's going to be 6 feet by 6 feet. Okay, so this force was derived from this uniform load by multiplying it um, by its span. Okay, so the feet cancel out, you're left with 24 kips. That force is located at the centroid of this rectangular shape right here. Okay, and that's going to be dead in the middle of this span right here, 6 by 6. Okay, so now that we know that, right, now we want to be able to find out what is our AY and our BY. Okay, so we do some of the moments in X direction, some of the moments about point A, some of the moments about point B. You're going to get 12 kips by 12 kips, which makes sense. In other words, if you do some of the forces in the Y direction equals 0, you have 12 kips going upward minus 24 kips coming downward plus 12 kips going upward equals 0. 0 equals 0. So you know that you are correct. Okay. Okay. So let me just clean this up a little bit. Okay. So now that we found our support reactions, we want to take it a step further. Okay. And we want to be able to find, first of all, we want to be able to find our shear force. Okay. And that's going to be in kips. Okay. So the first thing is our support reaction is 12 kips going upward. It's 12 kips. Now this is a uniform load. So it doesn't behave as your pointed load. So it's going to be a slope. Okay. And it's 2 kips per foot. For every feet that I'm traveling downward, I'm traveling by two kips over a 12 feet span. So 12 times 2 will give us 24. And it's going to be something like this. Okay. So once we get here, now we have our 12 kips. So from here to here, is nothing more than I'm going 2 kips per foot over a span of 12 feet. Okay. And then that brings me here. Then I have my support reaction BY, then bring me back up to 0. Okay. So this is right here is what we call a zero shear. Okay. Now that you've done that, we want to now go to our moment, which is kips per feet, is the units. And so again, when you want to find your moment, you have to look at your shear force diagram and look at the geometric shape, and you want to take the area under this curve. So this right here is a triangular shape, and it's one half, the area is one half the base times the height, and the base is 6 times the height is 12 times one half. So this is going to be 6 times 6, that's going to be 36. And it's going to give us a formation this way. The triangle gives us a formation that way. Okay? And this is going to be 36 right here. And again, this base right here, this distance right here is 6 feet. And this distance right here is 6 feet. Okay? And this is also 12, as we know. Okay? Here to here is 12, and here's another 12, makes it 24. But okay? And then now, this is below the 0 line. Okay, so your graph comes back down this way to 0. It starts at 0 and it must end at 0. Okay, we start at 0 here, we must end at 0. If you don't, there's something wrong somewhere. Okay, so our maximum bending moment happens to be 36 kip feet. Okay, all right, so let's try another problem just to make sure that we fully understand what's going on. This is slightly different, so I'm going to take as our solution, we're going to draw a free body diagram. This is A, Y, AX. AX is normally always 0 in this case because there's no forces in X direction. Okay, and this is my BY. Okay, now again, this uniform load is over. This uniform load, this uniform load of 2 kips per foot is over a span of 8 feet. Okay, so again, it's going to be 2 kips per foot times 8 feet. The feet cancel out. I'm left with 16 kips. So that's going to be the resultant force of this uniform load. And that's going to be located at the centroid, which is going to be half of that span. It's going to look something like this. It's going to be 16 kips, and it's located at half of that span. This is 4 feet. This is 4 feet. And I have another 4 feet. 4 kips. Okay, that's 4 feet. Yes, away. And then from here to here. Oops, I got that wrong. Sorry. Let me just erase this part. And we have another one, because this is 8 plus 8 is 16, 4, 4. So we have another one here. This is going to be your 4 kips. Okay, and this is going to be 4 feet, and this is going to be 4 feet. Okay. Now, what I would like to do now is I need to find my support reactions, AY and BY. Okay, so again, I can take my sum of the moments about point A equals 0. So this is my point of interest right here. The first force I come in contact with 16 kips, and it has a distance of 4 feet away. And when they come in contact, my force wants to rotate this way, creating a moment in a positive direction. So that's going to be 16 kips by 4 feet. Okay. So once I have that, then I'm going to have another, this 4 kips here. This is 12 feet away from the point of interest, A. And that force also wants to go in a positive direction. Okay. So that's 4 kips by 12. And then my BY minus BY, because this force wants to go that way, over a span that has perpendicular arm is going to be 16, right? And it's going to cause this force to go in a counterclockwise way. That's why I have a negative here, equals 0. If I solve for by, my by is going to be 7 kips, okay? Equals 7 kips. And then I could do some of the moments about point B, equals 0, okay? And when I do that, this is my point of interest right here. So the first force I come in contact with is 4 kips. 4 kips by, so I have a force of 4 kips here. Has a distance of 4 feet from point B. When this distant arm comes in contact with this force of 4 kips, it wants to rotate this force that way, making it negative, because I've told you in the beginning that I'm taking clockwise to be a positive rotation. Well, this is going to be a negative rotation, or it's going to be clockwise. So that gives me a negative 4 kips by 4 feet. Okay. Then as I scan this beam going from right to left, I see another force, 16 kips, and that happens to be 12 feet away from point B. 16 kips by 12, 12 feet. Okay. And then I have my AY by 16 equals 0. AY happens to be 13. Okay. And then let me just erase some of this off so we can have some room. So my AY happens to be 13 kips. Let me just clean some of this up a little bit. Okay. Okay. So we can be free, and then we can actually see what's going on. Okay. Okay, here. Okay. And then I'm going to take this away. Okay. Okay, so now that we've done that, we found our support reactions. You can test them. These forces, AY and BY, are going up, right? 13 plus 7 is 20. And I have 4 and 16 coming down. They cancel each other out. So that's how you know that your answers are correct. Okay, so now I'm going to take this a step further and we're going to do the shear force diagram. Okay, and we just draw these extended lines out, and then we have our horizontal line, x equals 0 here. This is our V, stands for our shear force, and that's going to be in kips. So we start from left to right, so we go up by 13 because our AY is 13 in the positive and upward direction. So this is 13 kips. Now mind you, once we're here, right here, we have this beam, this uniform load on this beam is 2 kips per foot, right? And it's going over 8 feet. So that's 8 times 2 is 16, right? So it's going to go from 13, we up 13, but we got to come all the way down here, and this is going to give us 3 at this point, right? Because once we cross this zero shear, we only have 3 feet, 3 kips per foot to bring us to our destination. Okay, it's 0 shear. Okay, now when we do that, there's nothing from this point here. We're right here. There's nothing in between here and to our next force. So we just draw a horizontal line. Then this 4 kips brings us down by 4. That makes us 7. We go across, and then we go up. Our BY is 7, and then we go up by 7. Brings us back to 0. Okay, so we started at 0. and we enter that 0. Okay, so now we want to be able to draw our moment diagram, kip feet. Okay, so let me just write this another color, kip feet. Now, as I said before, we want to be able to take the area of these different geometric shapes. Okay, now, but we don't know the distance from here to here. Please do not assume that's going to be 4. Please do not assume that. Okay, so what you can do is, once you know that the support react coming from the support reaction point of view, you're from this end, you want to know what is the base of this triangle as it crosses your 0 shear. Okay, so a good way of just doing that is your support reaction is 13 kips, right? And you want to divide that by your uniform load value. Okay, that's going to be 2 kips per foot. Okay, so it looks like this um, algebraically, 3 kips divided by um, 2 kips per foot, 13 kips. That's going to be 2 kips. Let me not do that part. It's KK, so I don't want to confuse anybody. Okay, I don't want to confuse anybody. Okay, and this is feet. Okay, and the kips, they cancel out, and I'm left with 6.5 feet. So from here to here is 6.5 feet. Well, if from here to here, oops, if from here to here happens to be 8 feet, then that means from here to here happens to be 1.5 feet. Okay, all right. So now, with that being said, I could take, now I know the base of this triangle. I know the height. I know the base. I can find the area. So that's 1/2 the base times height. And that's going to give me 42.25. And I'm going to draw this way. Start from my 0. This is my 0 line. It's going to go that way. That's 42.25. Okay. Kips feet. Okay. Now this area is below the 0 line. So my direction is going to change. And that's going to be 1/2 the base times the height. And that's going to be 1/2 the base times the height. Okay, so our base happens to be 1.5, and the height happens to be, because the area of a triangle is 1/2 the base times the height, so the base is 1.5 feet, and the height is 3. Okay, so that gives us 0.5 times 1.5 times 1.5. That gives us 1.125, and then we're typically going to subtract that. We're going to subtract that from, I'm sorry, 0.5 times 1.5 times 3 gives us 2.25. Okay, so this area right here, this area is, which is the same thing here, equals 2.25. But you have to subtract it from this 42.25 minus 42.25. That brings us to 40. Okay, so And again, since it's a triangle, it's an arc formation. Okay, we're here. This is going to be 40. Okay, at this point. Now, from here to here, this geometric shape is a rectangle, right? And that's 3 by, this is 3 by 4, which is 12. 12 from 40 gives us 28. So we're right here, 28. Now we come here to the next geometric shape. This is 7 by 4, which happens to be 28. And again, it's below the 0 line, so it has to come down. It comes back down to 0. Okay? So again, I started at 0 and I ended at 0. Okay? I hope this helps. If you have any questions, please just email me, and I'll be happy to explain to you how things work. But this takes some practice, and I just strongly encourage you to practice more and more, because you're going to need this information when you start designing beams. It's very important to know what is your maximum shear force, what is your maximum bending moment. In this case, your maximum bending moment is 42.25 kips per feet. Okay. Okay. Thank you very much. I appreciate you. Thank you. Bye bye.